The entire world is built on complex engineered systems, from the global supply chain to the smallest device in your pocket. To describe, understand, and design a system, you need specialized systems vocabulary. Today, we are diving into that particular lexicon, and we will begin with the fundamental unit of system science, the Holon. This term captures the structural duality of everything. A holon is simultaneously a whole unto itself and a part of something greater. Think of your smart thermostat. As a whole, it's an autonomous, self-regulating device managing temperature control of the room. As a part, it's a constituent element of the broader smart home system, collaborating and coordinating with other devices. This duality of has parts and is a part is what allows for the magic of systems, the emergent properties. This is the Holon's true identity. These are characteristics that arise solely from the coordinated interaction of its subholons. However, those parts alone do not possess this emergent property. But what is the primary emergent property of smart thermostat? It's a predictive comfort optimization. The sensor can report temperature and the processor can run code, but the ability to learn household patterns and anticipate when to activate the system to optimize comfort is an emergent property created by interaction with historic data. What about system's total power consumption? That's an intrinsic property, just the sum of its parts. There is one more type of property which holons possess, the absorbent property. These are characteristics the holon acquires from a supersystem which are pulled down. For example, the thermostat might absorb the utility company's tiered pricing schedule and then influence its scheduling algorithm based on that price data. The interconnected arrangement of all these holons forms what we call holarchy. This is the system's structure defined by two types of connections. First, the hierarchical links, the vertical chain of command. The central home hub, the superholon at level +1, sends a command to the thermostat, our focal holon, that is level 0. Below our thermostat, we have the subholons at level -1, the microprocessor, the sensors, and the communication module. Then the planar relationships or side-to-side communication with sister holons. The peer systems operating at the same functional level, like the smart security camera or a voice assistant speaker. To analyze a holarchy, a system thinker must establish definitive system boundaries. At the bottom, the irreducible. the smallest unit relevant to the study, say the transistor inside the thermostat. At the top, the cul-de-sac, the highest level where we stop our analysis. A system isn't a rigid model. It's a dynamic entity characterized by constant change. These changes are tracked through state and behavior. The thermostat's state is its summarized history, the cumulative record of occupancy patterns and heating response times. It's a processor of both current input and its past history. Change is initiated by a trigger like a person leaving a room, which activates processes like engaging the away algorithm within the Holon. This culminates in an event like the furnace shutting down until the system reaches the temperature equilibrium. A system must be viewed in relation to its three neighborhoods. We have the structural neighborhood, the physical connections, the behavioral neighborhood, the influence of its actions on other holons, and the conceptual neighborhood, the abstract context. This is like comparing the thermostat to a ship captain proactively guiding the resources. Concept of neighborhood teaches us to see up, down, and sideways, and in fact, to all devices to which the focal holon is connected. No complex systems can be designed or diagnosed unless you take the systems approach. So there it is. The systems lexicon, founded on the duality of the holon, provides the architecture for investigating modern complexity. It bridges the gap between the vague experience and clarity required for designs and predictions. With a simple example, we have introduced the basic vocabulary of the systems. Systems language is a white language like mathematics and hence can be applied to any type of system and particularly to concepts in pragmasophy. Pragmasophy is Prajna Yajna. Please subscribe to my channel and visit my website if you are interested in more explorations into actionable knowledge and systemic thinking. Thank you very much. Thank you.